At first glance, this question looks like it's going to be quite a complicated one, but with a little bit of concentrating on it, you can actually find out that it's a lot more simple than it first appears. Okay, now if you look, the question says that ABC and ABD are two right angled triangles. Angle BAC is equal to angle ABD, and that's 90 degrees, and that's this angle up here and this angle up here. AB is 13 centimeters and DB is 5 centimeters. Now, if you recognize from this, we can use Pythagoras, and we can say that A squared plus 5 squared equals 13 squared. So A squared plus 25 equals 169. Rearranging that, I get that A squared equals 144 and A equals 12. So this value here is 12. Once I've got to this point, I can start to use a little bit of SOHCAHTOA to help us with this. Now, I've got everything I need on this triangle on the right, the smaller triangle on the right, but I'm going to work with the sine of the angle, and I'm going to work with that because they're the two bits that were printed. Okay, so I'm not using my own value of 12. So when I look at this, I can see that I have I want this angle here. Okay, this is what I'm going to try and find. So if I find this angle here, then I can see that it's going to be sine of the angle is opposite over hypotenuse. Bit of a crazy H there, sorry. So opposite over hypotenuse. So the sine of the angle is going to be, in this case, 5 over 13. To find the angle, therefore, I do the inverse sine of 5 over 13, and that gives me the angle, and the angle in this case is the angle in this case is shift sine, and it's a fraction, so I'm going to put it as a fraction, and it's 5 over 13, and that gives me an answer of 22.6 degrees. So that there is 22.6 degrees. Using what we've got now, we can do quite a number of things. Okay, I know that this angle here is going to be 90 take away 22.6, which is going to be 67.4 degrees. This angle down here, because I've got, of course, a right angle here because it's on a straight line, 180 take away 90 take away 67.4 is going to be 22.6. And that only leaves this angle here to work out, and this angle, rather unsurprisingly, is 67.4. Okay? At that point, you can observe that the two triangles, as in the smaller triangle on the right and the complete triangle, okay, that those two triangles are in fact mathematically similar, because we have a right angle, 22.6, and we have 67.4. And on the big triangle, we have a right angle, we have 22.6, and we have 67.4. So at this point, we can come away from trigonometry, and we can actually look at the ratio. Okay, so if I orientate the two triangles in the same direction, then I can see that my first triangle is 12, 5, oh, all the way around, do apologise, 5, 12 and 13, with 22.6 and 67.4. And my larger triangle, which again I can show, is going to be there with 22.6 and 67.4. So because they are similar, okay, because they're similar, I've got this angle here, which is 12, okay, So the question now is a ratio question. What do I do to 5 to make 12? Because I then need to do it to 12 to make this value here, okay? So 12 divided by 5 is, let's clear all that, 12 divided by 5 is, that's useful, 2.4, okay? So 5 times 2.4 gives me 12. So I now need to do 2.4 times 12, and that gives me 28.8. So this value here is 28.8 centimeters. The answer to the question, work out the value of CB, is going to be 28.8 add 5, which will give us the answer of 33.8 centimeters. Okay, so our final answer, a little bit squashed in the bottom there, I do apologize, is 33.8 centimeters. So this question has some Pythagoras, it has some trigonometry, and then we can also finish it off either by using the sine rule, but I think that's quite an involved way. But what we can also do, because of the fact that these triangles are similar, is we can use ratio. So hopefully that's helped with that question. Yeah, thanks for watching.